Alright, how do you add fractions?
So once you multiply 3 times 5, which is 15,
Because we need
the denominator,
a common denominator. So you want this to become 15 and this to become 15. And you just said 3 times 5 got you there. How does that help you finish the fractions?
then you would do 2 plus 1.
Well, remember, think of these as candy bars, right? If you have a candy bar and you cut it into three
You do
pieces
the
and I take
diagonal.
one, it's not gonna be same as that same candy bar cut into 15 pieces and you keep one,
Yeah, so
right?
it'd be, the first one would be 6,
How did you get 6?
because you would go from 3 to 2 and then 5 to 1.
No, different concept you're thinking of. Instead, how did you get this 15?
I multiplied.
So if 1/3 is becoming something 15 and you multiply by 5,
Multiply by 5 and 2.
there you go.
5.
In doing that same thing, what's the top number on the other one?
2. No. 2 times 10.
2 times, what did you multiply this by to get that?
5. Oh, 3.
There you go. See, it's easier when you see it. So it's a
6.
6. There we go. Somebody take, good job. Somebody take it from there. Seth.
And you do 5 plus 6, and then you keep the denominator the same, so it's 11 over 15.
Okay. So if I would, in the original, have had -1/3 and -2/5, do you see how nothing was different, right? Because first I'd look at the signs, and I'd say, okay, I have a plus sign there, and I have 2 of the same sign, so I add and keep the sign, right? But all of this was the same, because that's how I add 2 fractions, right?
So when you have the, like at the original problem that you wrote, and it has the negative by the 1 and by the 2, does that mean the entire fraction is negative or just the 1?
It does, that's a good question. So if I have -4 over 5, that's the same as 4 over -5, even though you rarely would see it that way. And it's also the same as -4/5. Those are all interchangeable and all equal. When you're seeing a problem like that, you might see this version more often. I probably tend to write it this way because we didn't do anything with slope, did we? But slope is a geometric use of fractions, and it's best to stick that negative in the top, so that, for other reasons, my preferred way of writing that is to put it in the numerator,
Alright.
but those are all the same. And why are they all the same? Because if I would make this a decimal, -4 divided by 5 would be -0.8. So would that, so would that. So they all give me the same product. Bill?
If they were negative, would the top number be like in the middle section? Would the top be negative? Like
Say that
5
one more
and
time.
6. Would
That
5
was-
and 6 be negative?
Oh, yeah, if I kept going with changing that problem, yeah, thank you. Okay, so that's good. We're reviewing how to add fractions, but when do we add them? We add them when the signs are the same, whether they're both positive like we had originally, or they're both negative like we changed it to now, okay? Kind of combine 2 things there. Jimmy, you good?
Yeah.
Okay. All right, somebody remind me how I would do 7, can you see that color well enough? Okay. 7/8 minus, 1/4. Kylie,
Well, first you have to find a common denominator again,
we have to find it
and
again.
it will be 8.
It would be 8, good. Cause you could choose something bigger, right?
Mhm.
Cause like if I went back to what Colin did, I could get 32, but I just would need to reduce that at the end. So finding the smallest one is the most helpful. Keep going.
And then 8 times 1 equals 8, so then you do 7 times 1 and put that over the first problem. And then 4 times 2 equals 8, so you do 2 times 1, which is 2. And then
Okay.
you subtract 2 from 7, which is 5 and 4, 8.
Good job. Okay, so we got a common denominator. Went a little fast, I'll go through that again. These told me what my new numerators are. And like Seth said, denominator stays the same, and I work with the top numbers. You know, again, why are we keeping the denominator the same? Because think of that bar of candy. I keep picturing like a Hershey bar, one of those big old ones you get at Walgreens, right? If I cut that up in 8 pieces, you know, I can visualize taking 7 of them. You know, and if I have 7 of those 8 pieces and then you eat 2 of them, I only have 5 left. But the pieces don't change themselves.
How did you get the 8? The denominator.
Because Kylie knew that 4 went into 8, so I didn't have to get something bigger.
Oh,
You could do 4 times 8 is 32. And
So if a number goes into the number, you just subtract.
yeah, you want the least common
And how'd you get 1 and 2?
piece.
Yeah.
Because from here to here, we need to know what to do to that top number. So if 8 times 1 is 8, it didn't change, so neither is that gonna change. But 4 became an 8, so 4 times 2 gave me 8, we gotta do the same thing to the top, okay? So if we can remember subtracting fractions, then if I went through and said, okay, what if it was, that problem. Negative 7/8 plus 1/4. Well, the plus sign's between them, so we look at the signs. The signs are different, so we would subtract and take a sign of the bigger number. So this problem would still be this problem, and the answer would be negative 5/8, but the process didn't change. I'm gonna go through it again because I'm seeing some confused faces. If this was the original problem, we would say, there's a plus sign. So I look at the signs are different. So my rules say subtract, take the sign of the bigger number. So I subtract 7 minus 2, the bigger number's 7, so it's negative 5/8.
Also, you just do the same thing, but then just put the minus. I mean,
Because this one was bigger.
yeah.
So my point is, I guess I'm trying to keep it easier to look at by using the colors. I don't mean to be confusing you. All I'm trying to tell you is, you know how to add fractions, you know how to subtract fractions. Well, now instead of just thinking add and subtract fractions, think, what's going on with these 2 signs? Do they make me add because they're the same sign? Do they make me subtract because they're different signs? Great.
If we were showing our work and it was a subtraction problem with the negative in the first number, then how would could we just do it as a subtraction problem and add a negative to the
Definitely. Yeah. Showing your work, wait a minute. Showing your work is, still gonna be pretty much like just regular fraction work. And even though this one's negative, like when you subtract, you're still thinking bigger minus smaller, so you still set it up the same way. You just gotta go back and check the sign, yeah? Bill, was your hand up?